Okay, good morning, everybody. Okay, today video will be on the review for paper 1 and paper 2 for your mid-year paper. Okay, so you need to have this paper with you, okay, when we go through this. Now, this video will be a long one. What happened is the video will encompass a review of paper 1 and paper 2. So if you only need like paper 1 or specific questions at paper 1 or paper 2, please scroll the video to the respective locations. If you need like maybe paper 2 section B, okay, scroll it to the back of the video. If not, this video will be like maybe an hour long. It will be very, very lengthy. Okay, so now before without delaying anything, let's start. Now for the paper, let's see. Okay, paper 1. Okay, what you see on the screen is the paper 1. Okay, paper 1 for your mid-year paper. Okay, it's a 20 questions for science physics, followed by 65 marks for your paper 2. All right. Now, the answers for paper 1 is here. Okay. So if you have not marked or if you lost your answer sheet for the paper 1, okay, feel free to just pause the video here and just take a look at the answer and double check yours with them. Any mistakes, just let me know, okay, or let your teachers know. Now, at this junction here, right, what we are looking at is paper question 1. Now, question 1, diameter of human hair. This type of questions is what we call the logic behind physics. The one that we are testing is about the idea of whether students or science students are able to look at things with order of scale, big things, small things, how they do a basic pure assumptions or estimations of stuff. So these type of questions, it's hard to study except maybe like just get used to the questions or try out other questions to see what are the possible range of answers available. Now, the other one that we are looking at is this. Okay, second question: a stone throw is upwards. Okay, upwards from the top of the building. Okay, and describe the acceleration and the speed of the stone. Now, first thing first is when you say throw upwards. Okay, means the stone is actually thrown upwards. Okay, upwards. Okay, from the ground, from a building. Now, when we throw upward, this hint will tell you this will be a simple free fall question. Okay, it means the object is going in free fall. Now, what you are looking at free fall question is that normally free fall question, the first instinct that I tell students is you will know that the acceleration is equal to g, which is 10 meter per second square, acceleration due to free fall. So straight away you will know that among the options, A and B is out already. So the answer will either be C or D. Next thing is you look at the maximum height. Okay, at the top. Okay, the second question is the speed. Speed reach. The second thing I'm looking at is the maximum height. Okay, now this clue will tell you at maximum height, there are several things that can occur. At maximum height, okay, the common characteristic at maximum height is that the object will be up there at the maximum height. It will stay there for a while, momentarily, what we call momentarily at rest. So at this junction, you'll find that the speed at the maximum height is actually 0 meter per second. It will stop for a while. And then at this junction, same thing, your kinetic energy will also be 0 because it's not moving, 0 joules. But because it's still in the mid-air, it's still under the subject to the gravitational acceleration, the gravity pull, you'll find that the acceleration at this junction is actually your gravity, which is 10 meter per second square. Okay, so at maximum height, the characteristic we are looking at is the object will not be moving, 0 joules kinetic energies, okay, which is this particular answer. So that's why the answer will be C. So this type of question, usually I will tell students that you need to be familiar with the question to see what are the clues given to you and refer it back to your kinematics concept. Now, for question 3, what we are looking at is a classic example of Newton's law. Okay, I have a pulling force of 30 newtons moving at a speed. Now, first clue that you see is when I say constant speed. Constant speed, first instinct students need to have is you must take note that the acceleration is 0. And automatically, because acceleration is 0, you will know that by Newton's law, Newton's second law, F net, resultant force is actually 0. This is the first two things that you must take. The first information that you can infer from constant speed. Okay, then after that, same thing. What is the frictional force that is encountered? Means there is a friction in the surface in the picture. So while the object is moving to the left, the friction is actually opposing. So if you use Newton's law, okay, the net force for the object equal to ma. Net force, so the object is moving to the left, so I take left as positive. Okay, so it will be 30 minus friction equal to ma. Okay, remember what I mentioned? Since your acceleration is 0 because of constant speed, the right side of the equation, ma, will be 0. So automatically you will have 30 Newton equal to F. So my friction will be 30 Newton. So straight away, my friction will be 30 Newton C. Okay, so take note, the important thing for this type of question is to take note of the meaning behind the word constant speed. Now the second thing, the fourth question you're looking at is it's a classic kinematics question. Straight line, accelerate from rest. Okay, so travel a distance of 120 meter. Now, for kinematics question, the first thing that you look at, I will tell students is always draw the speed time graph. Okay, so for the speed time graph, okay, whether they give marks or don't give marks, draw the speed time graph. I accelerate from rest. Okay, from rest. Okay, accelerate from rest. Okay, this number is a fixed number, it's a constant acceleration, so that's why I know it's a straight line. And what so important about this straight line is that the gradient of the line actually is the acceleration himself, which is 10 meter per second square. Because kinematics, for speed time graph, the gradient is the acceleration. And after that, the question says, oh, the time taken to travel 120 meter. So what's the time taken to travel 120 meter? Okay, so now what is the important thing about 120 meter? For speed time graph, remember, speed time graph for distance, it will be the area under the graph. Even this area here, this triangle, will actually be the distance traveled, which is 120. So from these two information, you will see is that if I have distance is 120 meter, you'll find that the area under the graph will be triangle, which is half base times height. So the area under the graph will be half base, which is half base times height. Okay, the base is t, the height is velocity, a certain number, so 120. Okay, this will be equation 1. Useful or not, I don't know yet. But one thing for sure is that's the beginning. The second thing that I'm looking at is the acceleration is 10 meter per second square. Okay, acceleration is final minus initial speed divided by time. Initial speed, I know, is 0. So V, I don't know. So I know initial speed, final speed is V, initial speed is 0. Time taken is T equal 10. So this is equation 2, which will give me V equal to 10T. Okay, so this is equation 2. So what I'm going to do now is I'm going to substitute equation 2, okay, into equation 1 to find T. Because remember the question is to find T, yeah? So here what I do is half 10T, remember 10T times T, okay, 120. Okay, no space already, so let me write here, transfer my working here. So we have 10T times T equal to 120. So this will be easily 5T squared, simple math, you have 120. Okay, you plug out your calculator, you punch your calculator, you have 120 divided by 5. After that, square root, you get your answer T to be 4.898 seconds, which is roughly 4.9 seconds. Answer will be A. Okay, so what we are looking here is that take a look at this type of question. Although it's a MCQ question 1 mark only, but the working involved, okay, is actually quite a lot. The understanding behind it is actually quite rigorous. Some of us will say quite simple because it's a standard approach, but nonetheless, the math involved is not just a one-liner answer. Okay, so take note of the thing. Okay, most of the students, we have the idea. We have the wrong idea of like 1 mark. So if a 1 mark question, the working will be 1 mark. It doesn't work that way one. Okay. Question 5, nothing much. Just refer to your textbook, get the correct definition. After that will be all. Now, number 6. Number 6 will be the irregular lamina. So what happened is the center of gravity is at C. Okay. So I'm hung at O, so I can safely say this is my pivot. Now, with a pivot there, and the CG is here at C, means the weight is actually here. The weight of the lamina is here. Okay, now take note, if you take a look at the junction here, okay, let me draw a nice one. Okay, let me erase it. Okay, so let's say, all right, somewhere. Okay, let's a bit here. Okay, so if my weight is here, this is my weight. Okay, this is the weight of my object. You'll find that the weight, what happened is the weight, or what I call the line of action of the weight, actually passes through the pivot. Okay, actually passes through the pivot. So which means that at this moment here is I have the force, which is the weight. But the perpendicular distance from the pivot to the weight is actually from the pivot to the weight is actually 0. Okay, because the line of action cuts through the pivot himself. Okay, and because of these two reasons, or because of these two factors, especially the second one, the perpendicular distance is 0, you'll find that the moments is actually force times d perpendicular. Because d perpendicular is 0, you'll find that my moment is 0. Okay, that's why what happens is you will know that this guy will be called no turning effect. That's why it will be stable equilibrium. Okay. Now, this is a classic example of when we look at stability, whether the objects return back to the original position or topple. A classic example or classic approach where we look at how we solve it, will be looking at the force, perpendicular distance, and find the resulting moment, whether it's topple back or whether you return your the object to the original position or even doesn't move. Okay, so take note of it. Question 7. Okay, pressure. Standard formula, force equal F over A. Okay, just I want the least means I want the maximum. So for this to be small, the denominator will have to be the largest, or the area will have to be the largest, which is B. Okay, I would say it's quite straightforward. Now, this answer here, take note, there are several things to take note is what I mean by power output. Power output, general formula, you must know the formula is energy divided by time. Okay, the common booby trap that we have is you have to make sure energy is in joules. Most of the time it is in joules. There's usually wouldn't have other unit. The common thing that will trick us is the time. Time you must make sure it's in seconds. Okay, not other unit, not in minute, not hour, not in minute, not in hours. Okay, it has to be in second. Okay, the second thing I need to caution you is mega. Okay, mega here refer to prefixes 10 to the power 6. So what we have is the energy is 432 with 60 at the back. Okay, so if you look at the working, it will be energy divided by time. Let me erase a bit first. Okay, power. So power is equal to 432, 60 at the back, divided by time. 24 hours, remember, SI unit, 24 hours, change it to seconds, okay? 1 hour is 3,600 seconds. Okay, 24 hours will be many seconds. Okay. So if you punch your calculator, you press your calculator, 1, 2. Let me take a look. Okay, it will be 5,000 watts. Okay, it will be 5,000 watts, which is the answer here. Okay, 5,000 watts. Okay, so take note of the calculations. Okay, simple substitutions. Now, number 9, it looks like energy question. Okay, now the key thing to take note is when I say smooth. Smooth usually infer no friction. These are the things that I will tell you. If it's energy, when you talk about rest, it usually means V is 0, velocity is 0, object not moving, kinetic energy will be 0, half mv square, the formula. Okay, so now calculate the speed that it takes to leave the ball at the track at Q. The easiest, I would say, the approach that we are looking for is to use conservation of energy, which is energy at the initial equal to energy at final. Okay, so this is what I call the initial. This is the final Q. Now, before we solve, okay, look at the possible energy first. Okay, so at initial energy, the object, the ball is 3 meters high. So there will be a initial energy. Okay, there will be EP at the object here. Okay, there will not be any kinetic energy. Okay, because the ball is at rest. So the kinetic energy is 0. 0 EK. This is EK. 0 EK. At the final speed, you know that the ball, if you roll down all the way here, the most likely the ball will fly out of the way. So at this junction at Q, the ball is confirmed still moving. And also because of one thing, the question says the speed, the speed at Q. Speed at Q means there's a velocity at Q. I mean, there is a kinetic energy at Q. So which means I will have EK at Q. Okay, things to take note is, caution you is at Q, this is 1 meter high. So there is a height here that we are looking at. So when you have a height, means there is a potential, there's a gravitational potential energy, which means there's an EP at Q. Okay, so once you have the formula, the first thing that you do is you substitute the formula. Okay, so EP will be mgh. mgh is 3 meter. EK, I will not know, so it's half mv square plus potential at Q is mgh. The h is 1 meter. Okay, now this equation, how do I derive this equation? It comes from conservation of energy. Now it looks daunting, but actually it's actually quite simple one, because one thing to take note is the mass is constant. So I can actually eliminate the mass. Okay, so I don't need the mass. So I'm left with G, 3G, half V square and 1G. So effectively, I can do a simple manipulation. It will be 3G minus 1G. So I will get 2G here, half V square. Okay, so if you work out the math, let's see, it will be 4 times 10, square root, will be 6.3. So the answer velocity will be 6.32 meter per second. Okay, which is B. Okay, so this will be the answer for B. Okay, so important thing that we are looking at is to apply conservation of energy. Okay, after that, identify the energy at each stage. After that, let math take over. Okay. Now, question 2. Okay, the tank is filled. How about if it's solid iron? Okay, then the other one is air. So this is iron, this is air. I would say this is gas, this is solid. Okay, no color involved, so unlikely to be anything. So if it's gas, solid and gas, most likely there is a medium involved. Medium, if I'm looking at medium, if I'm looking at heat transfer, these two combinations, okay, most likely I would say there is a very high chance that it could be medium and heat transfer is more likely using conduction. Okay, but of course it could be I will not say it's not convection, because if convection, I will not give you solid, because convection doesn't occur in solid. If it's radiation based on the vector, I will need to know the colors, the texture, the size, even the temperature itself. Okay, so I'm given none of this from the question. So most likely it's just between solid and gas. Most likely it would be conduction. So how does conduction through X and Y, from X to Y? Okay, so to Y, so this is X to Y. Okay, moving downwards. Okay, downwards, it won't be convection. Convection will be upwards, and hot rise, cold sink. Okay, so most likely it will be conduction. Okay, so it will be either A or B. Okay, what is the main mode? The main mode means the fastest or the most. Okay, conduction occur best in solid. Okay, worst, it does occur in gas, but it's one of the worst. It's the slowest. So versus air and iron, because the question said main, so I will choose my answer to be B. Okay, conduction through air, conduction through iron, which is a solid, because conduction occur best in solid. Okay, so that's why my answer I will choose is B. Particle, number 11. Okay, states of matter, I would say it's a pure memorizing. Okay, so look at the formula, kinematics, kinetic model of matter, that particle topic. Okay, just go and take note of all the factors and memorize them. Evaporations, same thing, boiling and evaporation, a classic example of the difference between them. Now, one thing to take note is for the common differences in the textbook. If I'm not wrong, there is at least 4 or 5 differences. Okay, so students, you need to be like aware of the differences and especially memorize maybe 2. Okay, in case paper 2 they ask for it. Okay, so this one I will just take it as a pure memorize, refer to your textbook, nothing much. Now, question 13, just take note, is when we talk about ripples, when we talk about waves, okay, this is what we call wavefront. Okay, this particular setting is called wavefront. Okay, between each wavefront, let's say the wavefront is here. Between each wavefront, okay, the wavefront, between each wavefront, okay, between each wavefront, remember, between each wavefront is actually a cycle. Wavefront is actually the crest of the ripples. So if you look at the top view, you see this. The top view, you see from top, this is the top view here. Okay, so let's say I give an example. Let's say this is P, this is Q. Okay, so this will be P, this will be Q. Okay, looking from top, P and Q. Okay, oh, sorry. So this is P, this is Q. Okay. Now, between this wavefront, there is actually a wave inside there. So if you look at the cross section, the wave looks something like this. Okay, if you look from here, from the side view, you will see the wavefront actually refer to the crest of the wave. And between each wavefront is actually a cycle. Usually it's like a cosine curve. Okay, so with this in mind, you will know that from the source all the way out here, there is one wavefront, or there's one wavelength, second wavelength, third wavelength, and there's a fourth wavelength. So between, I would say, let's say A to B. Between A to B, there is from A to B. Okay, there is actually 4 wavelength, 4 lambda, and it takes, based on the question, it takes 10 seconds. Okay, it takes 10 seconds to travel from A to B. Okay, so effectively, I can say that with these 2 in mind, I can effectively say that for one wavelength, it roughly takes me 2.5 seconds to travel. Okay, so one wavelength time taken is 2.5 seconds. So one wavelength, remember, one wave time taken for one wave. This information, the time for one wavelength is what I call the period of the wave. And between period and frequency, the formula is, this is T. Frequency is actually 1/T, which is 1/2.5. If you take 1/2.5, you will find the answer will be 0.4. Okay, so the frequency will be 0.40 hertz, which is C. Which is A, sorry, not C. What am I saying? Okay, it's A. Okay, which is the frequency. Okay. So take note of the trick here. The important thing here is students need to know what I mean by wavefront. Okay, students need to know how to interpret this picture, what I mean by wavefront. Now, 14 is the uses of electromagnetic wave. This one I will not go through, just remember some of the uses for EM wave. Okay. Now, number 15. 15 is quite an interesting question. Now, from the question for 15, you'll know this air and this medium, P. Okay, and you know that for medium P, it actually bends towards the normal. So I can safely say that this guy is actually a denser medium. Air is a less optical medium. Okay. So if you look at the classic example, if you look at refractive index, remember the first booby trap that you must not make, or the first mistake you must not make, is the angles. For light ray, angle always measure from the normal to the incident ray. an incident ray. Okay, so the angle of incidence is actually not 40 degree, it's actually 50 degree. Okay, so angle of refraction is from normal to the ray itself, so it's 24. Okay, so this is my less dense angle. This guy will be my dense angle. Okay, the classic example that, or the formula that we look at is usually refractive index. It's actually sine angle in the less than medium divided by sine angle in the dense medium. Now, other than this formula, one of the other formula that's quite common use in refractive index, okay, would be speed, okay, of air in vacuum, okay, or the less dense divided by the speed in a denser medium. Okay, so this is what the common formula that we use. And in this question here, okay, surprisingly, we actually need both of them. Okay, because the question asks for the speed in the medium P, which is a denser medium. So if you use this formula, you'll find that if you use this formula, you'll find that the speed in less dense medium, which is air, speed in less dense medium is, you must know, speed of light ray in air is 3 times 10 to the power 8. Speed in the dense medium, which you're going to find. Left side will be sine angle in less dense. Angle less dense is, like I mentioned before, is 50 degree. Then the dense medium will be sine 24. Okay, so if you look at your equations, okay, so let's say sine 50, so I'll have 3 times 10 to the power 8. You do a simple math, okay, so it's 3 times 10 to the power 8. Let me do my calculator. All right, divided by sine 50 divided by sine 24. Okay, the answer will be 1.59, okay, times 10 to the power 8 meter per second, okay, which is B. Okay, now take note for this type of question, right? You have to know this formula, the difference in speed. Okay, speed in the vacuum or air divided by speed in the denser medium. Classic as refractive index formula based on the speed of the wave itself. Okay, so you must remember. Okay. Now for question 16 will be the clue that I would tell students to remember is, remember the 6 ray diagrams that we are supposed to memorize, the 6 ray diagrams. Okay, please know them. Usually in the textbook for us, discovery physics, it will be on page, I think 198. Okay, now take note for this guy is, remember, for the object to be real and magnified, there's only one particular instances, which means the object distance, u, okay, must be more than f, must be less than 2f. If I want to produce an image that is real and magnified, my object distance must be more than f, less than 2f. Not equal, there's no equal, it's more than f, less than 2f. So this is f, this is 2f. So for me to obey this, means the object must be within this range. So you will mean the one of possible location for the object, it could be at position 2, only position 2. Okay, whereby I have less than, more than f, less than 2f. Okay, so it's only position 2. Now for 17, okay, 17 is a classic example of pitch and frequency. Okay, so if I want, the keyword here we have is loud. Loudness, okay, we will know loudness depends on what? Proportion to the amplitude. Okay, the higher the loudness, the higher the amplitude, the louder is the wave. So if I want to have a louder, means that my amplitude must increase. Since this is the same wave, so no change in frequency, no change in pitches, nothing. Okay, because it's the same note that I'm referring to. So that's why the answer is B. Now, for 18, 18 is a classic, it's a standard electric field pattern for positive charges. For field pattern here, we are looking at, for field pattern in the O-level series, you'll find that there's only 2 types of field pattern. One will be the magnetic field pattern. The other one is the electric field pattern. So, and the good thing about the textbook is that it has quite a comprehensive or basic field patterns inside these two topics. So remember to refer to them, okay? And don't get mixed up. Magnetic field pattern we are looking at is magnets. Okay, electric field pattern we are looking at is charges, positive charges and negative charges. Okay, don't use the wrong words, okay? Now, for this particular field pattern here, okay, refer to your textbook for the correct field pattern. Okay, so I won't dwell too much, okay? But always remember, field pattern for electric is always from plus to minus. Okay, so you will know which is the answer here. Now, for 19, okay, charges. The word charge, current, and 1 hour. Okay, so you look at charges and you look at electricity, one of the common formula that we are looking at, it would be current equal to Q over T. Current is the flow of charges. Okay, now for this type of question, usually charges, you will know the SI unit will be in Coulomb. For time, take note, is always in seconds. So you must really go and convert yourself. Okay, so for in this case, you will take note that current is 0.30 M. Okay, 1 hour is actually 3,600 seconds. Okay, so I want to find a number of charges. So it'll be your algebra, you'll find that Q will be 0.30 M times 3,600 seconds. So that will be the answer, which is, I have no idea. Let's punch my calculator, will be 1080 Coulomb. Okay, so that will be the answer for C. Okay, take note of the SI unit when you use this formula. Question 2. Question 2 is the resistance formula. Okay, remember for resistance formula, same as current, I equal to QT. Resistance, there is a formula for it. Resistance will be rho LA, the resistivity, the type of cable, the length, and the area, cross-sectional area. Okay, so I have two scenario here, case 1, case 2. So for this type of question, I will normally use math to find an answer rather than to use logic inference. Yeah, I find that math is like safer. Yeah, so up to individual. Okay, I prefer to use math because math never lies. Okay, now for case 1. For case 1, okay, the resistance is R, given that the length, okay, I would say R1, okay, is R1, okay, at least it's R, okay, the resistivity is the type of cable, length is L1, A is A1, okay. Now, for case 2 now, for case 2, okay, the important thing is this, same material, length 2L, area 1/2. Okay, so now take a look. If the same material means I will be having the same resistivity as case 1. Okay, so it will be rho 1 also. Length is L2, A is A2, right? But based on the question is the material is the same, L rho 1. Length is twice the length of 1. So it will be 2L1. Okay, L2 is 2L1. Huh? Area is half of A1. So area of 2 is actually half of A2. Half of A1. Okay, so if you look at the math, you do a bit of manipulation, you will find that rho 1, L1, and A1. Okay, this will be a 4 at the numerator. Why? Because 2 divided by half. 2 divided by half, answer will be 4. Okay, so let's take note, when you do this type of manipulation, you find that rho 1, L1, A1, this factor here is actually here. So I can actually rewrite this to be 4R. Okay, so R2 is actually 4 times of R. So that's why my answer is D. Okay. So for MCQ, I would say it's not difficult. It's just need to pay attention to the basics. Okay, if you know the basics, I would say that the idea is like doable. Now, for give me a minute first. Oh, see. Yeah, okay, here we go. Now, for paper 2, let's go. Where's paper 2? Now, for paper 2, right? Paper 2, where is it? No, paper 2. Now, paper 2, section A. Paper 2, section A is a standard kinematics question. Now, kinematics question here, we are looking, Here we are looking at is speed time graph. Speed time graph, remember, the basic idea is gradient and the gradient and area under graph, which is the distance. Okay, these are two main concepts. Definition, yes, please remember them. Okay, definitely. What happened? Okay. No, so nothing much here. Okay, so please remember them. Definition, please remember definitions, be concise. Now, acceleration, when it's increase his speed, increase his speed, increase. So if you look at the graph, okay, the only timing whereby he increase his speed is only here. Okay, from 35 seconds to 50 seconds. So when I say increase his speed, okay, it refers to this junction here. Okay, so I will know that increase in speed means the final speed is 20, the initial speed is 0. It belongs to this section here. So that's why I know if you look at acceleration, final minus initial, you'll find that my final speed is 20, initial is 0. So that's why I know it's 20 minus 0. And I also know the timing is 35, in between the 35 range to 50 seconds. Okay, because increase speed, based on the graph, only this section only. This is the section that I increase speed. Okay, then after that, I use the acceleration formula, answer will be 1.3 straight away. Now, calculate the distance traveled by the motorcyclist when they move off the traffic. Okay, now, based on the questions here is this. The question says, at 20th second, he stopped at the traffic light. So this is the traffic light. I stop. So at 20 to 35, I'm at the traffic light. I'm still at the traffic light. At 35, I move off. Okay, so when I say I move off, okay, what I'm looking at here is from where? 35 seconds all the way to 80 seconds. Okay, so what I'm looking at here is the time frame is, this is the move off time frame. Okay, and I want the area, I want the distance traveled during this timing. So this will be the, so when after I move off, right, the traffic light. So this will be the area I'm interested. This will be the area. After I move off on the traffic light, it will be this trapezium. Or sometimes we call this a triangle, two triangles and one rectangle. So you, to find the distance, you need to find the area. You need to find the shaded red area. Okay, which is this formula here. This one is the triangle. This guy is the rectangle. And this will be the triangle. Okay, remember, distance under this for kinematics, distance travel is area under the graph. That's why I look at these particular shapes. Okay, and why this particular shape? Because the question says move off. I move off from the traffic light. Okay, and it will be from time 35. Okay, so you have to read the question carefully. There's a bit of analysis looking into it. Now, on a calm day, second question, the balloon. Okay, the balloon weight is, where's the balloon weight? The balloon mass and the passenger is 600 kg. Okay, take note kg. Okay, and here I look at the tension in the rope is 500. Okay, so the balloon, what you're looking at is the balloon. You'll find the balloon. Okay, the weight of the balloon is here. Weight, I'm not talking about mass. So which means my 600 kg, I need to convert to 6,000 Newton. Okay, how do I do that? Okay, classic, the simple weight, simple formula, weight equal mg. Okay, so my weight is downwards and I have a tension in the rope. Okay, now the rope tension, okay, is pulling the object down. So this will be the tension in the rope. Okay, and after that, I have an upward force here. Because why? Because of the balloon, the hot air balloon is going to float up, you're going to push it up. So there is actually an upward thrust here. So this will be the lift force, the upward force. Okay, so if you look at the force that you are looking at, upward force. Okay, that's the wrong symbol. Okay, instead of leave, based on the question, this is U. Okay, so the triangle, the question will be like this. Okay, so I will have tension U followed by weight. Okay, so it'll be in this three direction. Your weight is down, your tension is down, your up force is due to the upthrust by the hot air. Okay. Now, same thing, Newton's law. Okay, when I cut upward force, okay, same thing is the balloon is not moving, so same thing, I take up as positive. Okay, I take up as positive. So it'll be U, 2 downward force, W and T, U minus T. Okay, that will be the resultant force. Okay, then after a 0, why? Because the balloon is not moving. Based on the question, it is not moving. So acceleration will be 0. Okay, and after that, do a simple math, you get answer 6,005. Okay, so you have the upthrust being 6,005. Now, the question says I cut the rope. I release the rope. The moment I release the rope, this information, what does it tell me? Okay, this means the tension in the rope, the symbol used, tension in the rope T. Okay, tension in the rope, okay, will be 0. Okay, so instead of 3 force, just now we have is one is upward force, there's one weight here, there's a tension. Okay, so there's a tension. So now what happens when I cut the string? When I cut the string, tension force is disappear. I only left with 2 forces. I only left with U, upward thrust, which is upwards, and this is upwards. Okay. Now, same thing. Since the object now is moving upwards, because the tension, the rope is cut. Okay, so what's the resultant force? Let's say moving upwards. I'll take up as positive. So it'll be U minus W, which is here, which is 500. Okay, so the upward force will be 500. What's the acceleration? Simple F over ma. Sub the formula in, you get answer 0.83. Okay, simple substitution of Newton's second law. Okay. So I hope this topic, this question, I think the only difficult question is that this question 2 is there's a transition whereby the tension is being tied down, the balloon is not moving. Then after it transit to question B, part B, whereby the balloon is moving upwards and there is a small factor involved whereby T is 0. So the students need to take note of the transition. So the questions require the students to take note of like what happened before and what happened after the transition. So during the transition, T is 0, students need to know what does this mean and how does it affect the equations, how does it affect the Newton's law. Okay, so I would say it's like slightly difficult. This question is slightly difficult, but I would say it's manageable. It's still manageable. Okay, question 3 is definitely an easy question. Okay, standard question of the mass weight or density question. Okay, weight is 2 Newton. Okay, weight. Okay, weight of moon. Okay, G of moon. Okay, this is the G of moon. Okay, standard formula, weight equal mg. This formula everybody must remember. Okay, everybody must know. So question 1 shouldn't be a problem. Only booby trap I lay for you is, the only booby trap I have for you is it has to be in grams. So a lot of you have 1.25 kg. You need to convert to grams. Okay, then after it shouldn't be any difficult. Difference between mass and weight. Okay, just take note what you are writing. Okay, know the differences. Is in the book or it's actually part of your knowledge as a physics students. Okay, you should know what's the difference between mass and weight. Even though commonly we tend to use these two words like interchangeable, but fundamentally in terms of scientific content, mass and weight are actually two different factors. Okay, they are describing or they represent two different things. Density, formula mass over volume, nothing much. Okay, volume 170 given in the question, you plug the formula in, the answer should be out already. Okay, just be careful. Question 3, quite easily done. Now, question 4, Alfie and Adi. Okay, Adi and Alfie play on the seesaw. Okay, this is Adi. Okay, which is the 500 Newton. 550 Newton, sorry. Alfie, which is 600. Newton. Now, first thing, definitions. Okay, if you look at principle of moments, a common thing that we have is we always mix up principle of moments definition with definition of moments. They are different. Okay, so if you look at definitions, students, you need to know what are the definition the students, the teachers, the marker require, and give the correct one. For principle of moments, right, if the definitions, there are three key things that you need to write. And most of the time, students actually we always remember to write the second one. Always. Okay, total clockwise equal to anti-clockwise moment. This one everybody remember. What students forget is they always forget to inform the marker to say that this principle only works if the object is in equilibrium first, and if the moments is actually calculated about the same pivot. So that's why when you look at principle of moments, you look at the definitions, you'll find that there's three parts in this definition, the three essential sections that you must give. Okay, and this is the three sections. Okay, so students, please remember, leaving out any of the section here will actually cost you some marks here. Other than that, okay, same thing. Standard analysis, this guy will be your anti-clockwise moment. Okay, then after that you will have a clockwise moment by alpha. Okay, and the question, take note, the questions never say it's balanced yet, so we cannot assume it's balanced. That's why the question say what happened to the seesaw. Okay, so based on the question is that students, you will need to actually calculate on your own what is the moment by RD, what is the moment by alpha. Same thing, moment is force times distance, force times perpendicular distance. For alpha is 600 Newton, perpendicular distance is 1 meter. So it will be 600 Newton meter. Okay. For RD will be 500 times 1.3. Okay. So you'll find that for RD, 500 times 1.3, the moments here I'm looking at is 650 Newton meter. So RD, moments caused by RD is actually higher than moments caused by alpha. Okay, so the left side is actually the moment is stronger. So that's why the seesaw will actually rotate anti-clockwise. Okay, so that's why how I get my answer. Okay, because RD, moment by RD, is actually higher than moment by alpha. Okay, as a result, you rotate anti-clockwise. Okay, and this is the reason. Okay, so you need to actually calculate, do a slide, like a calculation on your own. The question never asks for it, but to answer the question, you need to actually do the calculations. Okay, so don't every time expect the question to ask, then you give. Okay, so you must anticipate the questions. Okay, because certain questions really, we take it as a calculations is actually underneath the underlying procedures that you automatically do yourself. Okay. Emily, now question 5, cone shape. Okay, you want a cup, not a topper. Okay, so standard definition, please memorize them. Now, stability, improve stability. Remember, there's two common reasons is actually to lower the CG or to broaden the base. Now, the question here is most of the students, right? You will actually remember what is the what is the answer? Okay, whereby it's lower the CG. Okay, you will tell me it's lower the CG, and you will tell me is to make a broader base. So sometimes you will tell me it's broader base, but you'll find that if you use broader base, this word, okay, it's a bit ambiguous because the question says state one way. You need to tell me what is the method that you do, okay? And one of the things when you talk about cup is to broaden the base, right? To make the base wider here, you need to tell me exactly what it is. So that's why one of the questions here that we look at is when you tell teacher, when you tell in your answer, right, you state that to make the base wider. Okay. But if you make the base wider, right, you'll find that we don't accept the answer because why? If you make the base wider for this question here, how are you going to make the base wider without spoiling the cup itself? So you can't do it. Okay, some of us we are quite creative. We say we will turn the cup upside down. Okay, but if you turn the cup upside down, yes, it does. It does make the base wider now, but your cup is facing down. You can't use the cup anymore. So why do I want to use the cup? Okay, so that's why if you talk about certain logic or certain common sense behind the question is that I can't accept any answers that fits the concept. For example, base wider. I literally can't accept base wider because there is not much of a method I can use to make the base wider without compromising the cup function. So that's why you find that some of us who use the word base wider, even you tell me upside down all these things, you find that the marker will not agree to that and will not give you the marks because you actually compromise the usage of a cup. Where the common, I would say the one of the good answers that we have students pouring water into the cup. Pouring water in the cup because what happened now is the base is actually heavier now. So the CG will be lowered and the stability of the cup will be increased. And I can still use the cup as a cup. Okay. So take note, okay, don't just blindly throw out all the answers or the solution in your textbook. You have to ask yourself, is that does your answers answer the question? Right? Does your answers suits the question? Okay, that is the more important thing. Okay, rather than just memorize, regurgitate everything without any sense making. Okay. Question 6. Question 6 we have is I would say it's a heat transfer process. Okay, the common answer that we have, freezing unit, expanded polyester. Okay, the common thing about polyester is like sawdust, styrofoam, all these things. Students need to know that they are like bad conductors. Okay, so these are like bad conductors. They are like the medium or the materials. So when we talk about materials, we are referring to conductors. So if we talk about when we talk about conductions, okay, when we explain conduction, there is a standard standard keywords that students have to write. So the students will have to write that identify it is a conductor, poor or good conductor. State the quality of the conductor. Then after he will have to tell me the heat transfer process. So and he had to use certain keywords like conduct. So he must say the heat is conducted from the location from outside to inside. Okay, I need the location. And of course, being a poor conductor, the heat conducted will be at a slower rate. Okay, so if you look at the keywords, okay, the keywords, I think your teacher will have given you for conduction, good conductor or bad conductors, the keywords I usually break down into 3 sentences. You have to tell me the conductors, who are bad conductor. You have to tell me the location of heat transfer, whether it's transferring from out to the exterior or it's transferring to the interior, plus to use the command word or to use the important keywords of conduct to highlight to the marker that you know is conductions. And the third one that I need to write is to tell me the rate, whether it's slow or fast. Commonly, I will tell students that poor means slow rate, basically. Okay, so there are certain keywords that are tagged together. Okay, so for expansion, for conduction, there is no expansion. For conduction, there are certain sets of keywords or there's a standard procedures or a standard sequence to the answer. Okay, so just do take note of the sequence. And likewise for convection also. Convection, we look at is there are certain sequence when we look at convection current. When we look at convection, it's not just the direction, hot, rise, cold, sink. More importantly, you must tell me the reason behind it being the changes in density. Okay, so if it's less dense, why? Because it will rise, because the item is hot or warm. Cold, okay, sink, because it is denser. So the keywords packed to the process is quite, I would say it's quite standard. Okay, so hot rise, okay, because the reason less dense, the cold sink because it's denser, then convection current will occur. Okay, so when you look at the answering stem on the answering structure for this type of question is you have to highlight which liquid or which fluid, the direction of the fluid, rise or sink, followed by the reason behind it being the changes in density. These are the 3 things that the students need to highlight. Okay, which is why it's always being phrased this way. Okay, so take note of the structure in the stem of the question. Cooling curve, heating curve is a standard thing. Okay, I will not dwell too much on this question here, but just take note when we talk about flow of energy. Flow of energy in the notes or in your textbook, you'll find that the common thing that we have is I always tell students that flow, how does thermal energy, how does heat flow? Only one direction. You always go from hot to cold. This is the direction that heat always flow. You always go from hot temperature, hot to cold. So in this question here, because the object is removed from fridge, you have to read the question. It's removed from fridge. So which means that the object is actually colder than the surrounding environment. Okay, so the heat transfer direction we are looking at is because the object is colder than the environment, heat transfer will be from the exterior to the interior. Okay, and this is based on this clue that is given, is removed from the refrigerator. So that's why I know that direction of flow is always towards the test tube. And one of the other hint that I'm looking at is because of the graph, you'll find that the temperature is rising. Okay, so which means the object being it means colder than the environment, he will actually absorb heat from the environment. And when I absorb, what's the outcome? The object actually heated up and the temperature increases. Identify the state. This one quite easy, solid state and liquid state. Okay, just take note of the word. Don't use anyhow. Okay, don't leave out the state. Okay, just take note of the timing, 6 to 12, 18 to 24. Cooling curve, just the common thing about cooling curve is actually to know that this constant temperature is the change in state. So there's a phase change, the change in state, the change in phase. Okay, there's a phase change. Okay, from this side, it will be from solid to liquid. This will be from liquid, changes to gas. Okay, nothing much. For classic examples, okay, for changes, take note, 18 to 24. 18 to 24 here refer to 18 to 24 here refer to boiling. Now, for boiling, okay, the keywords that we always tell students is boiling, there's two particular important procedures or two particular important stage. The first stage is the have to break the intermolecular bonds. Okay, the first stage to break the intermolecular bond. This particular stage is for where? For the object to change from liquid to gas. Okay, this is where the boiling actually occurs. Boiling refers to liquid to gas. Okay, and how do I do it? The important thing that students have to use is to achieve state change. The important thing is overcome intermolecular bonds. Intermolecular bonds is like we in physics we are a bit particular about this. It's like the bonds here we are not looking at covalent or ionics, okay, because we are just loosely lump everything as a term called intermolecular bonds. So students, we usually don't encourage you to just use the word bonds or force. So the correct terminology for this general description is actually intermolecular bonds. So you have to actually remember to reuse this word, but this is one of the keywords. So this is the first stage that the object undergo during boiling. The second thing is for gas. Gas for object, for the liquid to become gas. One of the important characteristics of gas is that the gas actually is allowed to roam the surface, roam the air, spread out, diffuse. The gas actually can move. So for the gas to diffuse or to move around, one of the important things is one of the usage for the energy. I absorb energy from heat is to do what? Is to push back atmospheric pressure. So when the gas particles has extra energy, what does it do with the energy? You actually use to push back the air molecules so that the gas particle can actually go in and actually move around the environment. That's how gas travel. Where for gas to travel, they literally, after breaking the bonds, intermolecular bonds, they actually need to also have energy to push back the atmosphere. If not, the gas will just be staying there. It will not be roaming around. Okay, so these are the two important stages we are referring to when we talk about boiling. Question 8, ripple tank experiment. I find that it's quite okay. Student did quite well for this. Okay. Maybe like some like small miscalculation mistake. Amplitude. Okay, it's always from the equilibrium, the zero, to the top, or it can be from the 0 to the trough also, to the base. Okay, but not 7 to 7, not the whole line. Okay, not the whole line. Okay, it is not the whole line. Okay, amplitude is always from the base, either go up to the crest or go down to the trough. Okay, okay, not the whole entire length. So sometimes I have students giving me 1.4, which is wrong. Okay, other than that, nothing much. Basic formula, VF, lambda, SI unit, all these things. This question, I will not dwell too much on it. Okay, wavelength, most students have no problem with it. Okay. Isolated charge. Okay, this one is a standard. This is electric charge. Okay, refer to your textbook for the pattern. Okay, is there refer to textbook? Okay, it's in the textbook. This is pure, I would say just remember. Okay, so I will not spend too much time on it. Okay, likewise, for the definition. So this two is a giveaway question for students. Okay, just refer to textbook, copy and paste, I would say. Circuit. Okay, circuit. This circuit, I would not say it's complicated. It's just that students need to be careful of the arrangement. Okay, now from this arrangement, one thing to take note is that this two is not parallel. It looks like parallel. Parallel has to be in this formation. Up and down, solely up and down. Okay, one resistor up, one resistor down. Nothing left or nothing right. But you find that this 4 ohm, there's something on the right. Okay, and it's not just 4 ohm above 5 ohm. 4 ohm is above it and 2 ohm is above it. So it looks like parallel, but it doesn't look that way. So which means you cannot sum the resistor in parallel yet. Okay. So what we do now is we look for another sequence. Series, side by side. Yes, you know this is definitely series. This is definitely series. So you can add them straight away. So this type of question, if you transform the circuit, you add up, simplify the circuit. This is K, this is M. Okay, on top, okay, on top is this, on top will be this, below will be this. Okay, so I will label this as series 2. This will be series 1. Okay, so now once you have this, you will find that these two is parallel to each other. Okay, so this is in parallel to each other, so you can sum them together. Okay, so this is how I reduce the circuit. Okay, from a 4 resistor circuit to down to a 2 resistor circuit, and finally to a single resistor. Okay, or RT. Okay. Now, so look at the question first. Calculate the series total resistance in the path KLM. 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 Okay, KLM, which this path will be a simple 4 plus 6, which is series. I will nothing fanciful. Total resistance between K and M. K and M. Between K and M. Okay, between K and M. Okay, which is AKA what I call the total resistor. Okay. Now the total resistor that we have here, total resistor, okay, it will be RS1 and RS2. So I will say RT is actually what happened? RS2 and RS1. Okay, so it will be 1 over okay, what is it? Blinking? Oh, let me see. Okay, give me a while first. Let me stop sharing for a while first. I wonder what happened. Okay, why is it blinking? Okay, let's try again. See, is there anything wrong? Okay, let's hope. Oh, what happened? Oh, I have no idea. Why is it blinking here? Maybe some alert. Okay. Okay, let me try for one first. One for one. Right. Okay, let's get back. Okay, now where I was saying that now the question asks for the total resistance of Km. Okay, so total resistance between K and M. So it would be 1 over RT, which is the R parallel, basically it's 1 over RT equal to 1 over RS, 1 plus 1 over RS2. Okay, so this is where you get your 1 over 6 and 1 over 8 here. Okay, for your working. Then after the current through the battery. Now the current through the battery here will refer to the total, refer to the current through the battery will be battery current through here. Okay, so this will be the total current going through the whole circuit. So the easiest one I would say is I will just use a total Ohm's law. Okay, total voltage, the current going through, it will be the total current followed by the resistance total. Okay, it will be the total voltage, which is the EMF. Okay, so the total voltage here that we are looking at here is 12 volts, which is the EMF. Okay, total current you're supposed to find. RT you found in the previous, which is 3.43. Okay, so you have the answer will be 3.5. Okay, so there will be current going through the battery, the total current in the circuit. Same thing, the current through KLM. Now, KLM, the current through KLM. Here you will know that this is a classic example of parallel. Okay, so which means I would say that it is parallel. You'll find that the potential difference, okay, is the same as here. Okay, so the potential difference across these two branches is actually the same. So if my potential difference is 12 volt, this will be 12 volts. Okay, so the potential difference across RS1 is also 12 volt, and the potential difference across RS2 is also 12 volts. Okay, and since it's 12 volt, I can use a standard Ohm's law. Okay, V equal to IR. Okay, current in KLM, potential difference across KLM, okay, over the resistance at KLM. Okay, like I mentioned to you, okay, KLM is here, voltage is 12 volts, resistor I know is RS1. Okay, so if I know this RS1 and 12 volt, I can literally find the answer 12 volts, and this is 6 ohms. So I can literally find the current using algebra, V equal Ohm's law. So answer will be 12 volts, 12 amps. Okay. Now, potential difference across 2 ohms. So where is 2 ohm first? Okay, 2 ohm resistor is, let me erase first. It's a bit messy here now. Where is the 2 ohm? Now the 2 ohm resistor is here. Okay, I want to find the potential difference across the 2 ohm here. Okay, so one of the easiest way to have is, since I have the current in this branch, the current will be the same throughout the branch. Okay, so likewise, if I want to find the potential difference here, I can just use Ohm's law, V equal IR, because I have the current, I have the resistance. Okay, which is what I'm doing. Okay, V2 across 2 ohms, I will need the current across 2 ohms and the resistance across 2 ohms. I2 here is actually IKLM and R2. So that's why it's 2 ohms, 2 amps. Okay, so you can use simple resistance formula, Ohm's law, all these things. Okay, but take note, okay, when you talk about Ohm's law, the formula that I'm looking at is actually V by R, and maybe the resistor formula and the resistor formulas and series and parallel. Okay, but you must know where to apply, where to write the formulas. Okay. Now for section B, question 11 I think is quite badly done. Okay, because I think students tend to forget what I mean by magnifications. Okay, magnification, take note. Okay, magnification, there is a formula for it. It's actually image over object. Okay, it can be the various property. It can be the distance image divided by the distance object. Okay, so it can be distance over of the object, or sometimes I can say is the height of the image of height of object. Okay, so how do I get 1.7? It's actually 8.3 divided by 8.3 divided by 5.0. Okay, you get 1.7. Okay, it'll be height divided by object. So height, okay, so you have to take note of all these things. Okay, so you'll be height divided by height of distance divided by distance. So it's always object on the numerator. Image on the numerator, object on the at the denominator. Okay, so it can be height over height or distance over distance. Okay, so you get your answer straight away. So how do I? So for example, so if you bear this in mind, okay, you'll be able to find the two answers here. Okay, so which means I would say the magnification is 0.33. It will be, let's say x, so it'll be x divided by 5. So you'll find that your answer will be 1.65. Okay, so x will be 1.65. Okay. Now, set 1. Okay. Set 1, take note. Okay. Set 1 is object is 30, 30. Okay, so which means if I have the lens, let's say I set the lens to be here. Okay. If the object is to, let's say if I set the lens to be here, object is 30 cm, 1, 2, 3. So this is where my object is. Okay, now take note. Okay, this is where my object is. What's the height of the object? The height is 5 cm, 5 cm. So it will actually be half a square. So this would be my object. This would be my principal axis. Okay. Image is 30 cm. Okay, so this will be 30 cm. Okay, based on the question, height here would be 5 cm. Oh yeah, sorry, I forgot to amend the question. This scale is 10 cm and 10 cm. Okay, so same thing, ray diagram. Okay, first you draw ray 1, okay, which is object to object. It cuts through the optical center. Okay, this is the first ray. It cuts through optical center all the way straight. Okay, from object to image, cuts through optical center. Okay, after remember, put arrow. Okay, arrow represent light rays. Second one is like ray 2. Okay, ray 2. Ray 2 go straight. Okay, hit the lens. After that, you cut through focal point and you go through the head straight away. Okay, so you cut through, so remember put arrow. Okay, once you have, you'll find that you'll cut through the focal length, F. Okay, you do it nicely on the paper. I think the answer will be 15 cm, maybe plus minus a bit, 1 cm, like 15 to 16 cm. Okay, so just take note of the answer. Okay, this is how you draw the ray diagram. Ray diagram, take note, do not anyhow draw. Ray diagram, there's only 3 rays that you can draw, because this 3 ray has fixed answer, fixed locations. Okay, so you can only draw these 3 rays, and from there you move on to see where's the intersection of the rays to give you the image. And from there, you can decipher the location, the property of the image itself. Okay. Now, question 5, for medium. Okay, take note, the important thing is here. Okay, the lens that we are looking at, this is the angle I'm talking about. This is the angle I'm talking about. Light ray is always measure angle from the object to the from the ray to the normal. Okay, I don't know why my screen is blinking. Okay, I hope it's on your side. It's not, you are not seeing it, because I don't know why my screen is blinking. Wait, don't know why. Okay. Okay, but get back to the question. Okay, now 4B. Okay, the ray is always from the ray, the angles is always from the ray to the normal. Okay, so the angle of incident is actually the angle in the medium A is actually 40 degree. That's the one that you're interested. Huh? So how do I know who is less dense, who is denser? Okay, classic thing is it has to be bent away from normal. Why? Because you know less dense, optically less dense medium actually always cause ray to bend far further away. Or sometimes we can say we cause the ray to speed up. Okay, or the ray to speed up. Either way, bend away from normal or speed up. Either way, we accept. Okay. Now, reflecting index less dense. Okay, remember less dense to dense. Okay, less dense. Okay, less dense. The angle we are looking at is 40. Not 50. Okay, sine 40 is at sine 40. Okay, less dense to dense. Okay, it's not angle big. It's at the numerator or denominator. It's angle at the less dense medium is always at the denominator. Okay, so then that's how you get the answer. Now for part C, right, here you need to take note. Okay, you have to work out the critical angle yourself. Okay, based on refracting index 1.47. If it's 1.47, right, you'll find that the critical angle, okay, the critical angle 1.47 refracting index, you will find that the critical angle is actually 42.8. Okay, or 42.9. This is the critical angle. Okay, so when I increase to 55, okay, 55 is definitely more than the critical angle. And because of that, I know the total internal reflection will occur. Okay, and same thing, the standard three, if we talk about explanation for total internal reflection, the standard three phrases we have is here. It's always you have to tell the marker is from dense to less dense. It's always more than critical angle. And because of that, total internal reflection occur. Whoa. Okay, so that's why this, when we talk about internal reflection, total internal reflection, this is what we call the 3 sets of keywords that we always tell the marker, or when we want to explain total internal reflections. So students, you need to make sure you have all these 3 sets of keywords. Okay, because this is what the examiner are looking out for. Now, part 3, question 12. Question 12, question 12 is sound. Sound your total internal reflection. Total internal reflection, what I'm saying. Okay, sound is your echo. Okay, your reflection of sound. But here, take note, is your distance you actually travel 2 times, 1 and 2. So there's a D and there's a D. Okay, so effectively your distance traveled you is not thus 1002, it's actually double of it. Okay, a lot of students you forgot to double, you just use 1002 only. Okay, always remember echo, the reflection of sound. Okay, the object, the sound actually travel down and up. So the distance you are talking about is 2 times the distance. So you must always remember to double the distance. Okay. One differences between the pulse. Okay, here if you think the pulse itself is not about the environment. Some of you tell me that the answers for this is like all the common difference is where the pulse travel. Okay, but it doesn't. Example like the you tell me that the pulse from the ship actually to the seabed actually travel a longer distance as compared to the pulse from the bed, from the fish. So you travel a shorter distance, one travel a longer distance. Okay, now the question thought about is the pulse is himself, pulses himself. Then what are the difference between the pulses? Not where the pulses has, not the environment where the pulses exist. So that's why the answer that we accept is usually things that pertaining to the pulse itself. That's why we only accept these two. Okay, particularly the last one. This is the best, the better one. Okay, so I will not dwell too much. It's quite common sense. Okay, explain how sound wave is transmitted. Okay, now sound wave is transmitted. How sound is transmitted? Okay, I would say this type of question is quite common, and it always has these two answers that we always give. sound is transmitted, the answer is always in two parts. First part, the question always need you to define what is longitudinal wave. Okay, so the first part of the answer will involve you defining the definition of longitudinal wave. Then after that, the second part actually involve you telling me a series of refraction and compressions. Okay, because of the motion of particles, the motion of the particle himself in a certain manner, it causes collision and it causes a series of refraction and compression. And that's why this is what I mean by the two section keywords I'm looking out for when I need students to explain to me how sound is transmitted. Okay, so this two is a standard set. If you miss out any one, it will be deemed as incomplete. Okay, so please take note of your answers. Difference between sound and light are quite common. Please remember them. I will not dwell too much. Okay, now feasible thing about sound wave here is that the important thing about sound versus light is that for light to reflect, I need a smooth surface. I definitely need a smooth surface. So, and because of that, I can't use it in C because the C bed is actually quite rough. If I shine the light all the way down to the seabed is rough. I will not get the light ray reflected at all. Even if the light ray reflected, because the seabed is rough, I cannot control where the light ray will reflect. Okay, it could be I shoot down to the seabed, and because of rough surface, irregular surfaces, the light ray could be reflected, bounce off to maybe to the left side, right side, or even to any other side. So I cannot control where the light ray travels back. And because of that, I can't use light ray to control or to search for the fish himself. Okay. Now, for seabed, warmer. Okay, here warmer, the keyword here we're looking at is warmer. Okay, for warmer, we are looking at the particle is more energetic. The particle vibrates more. And because the particle vibrate more, the speed of sound is actually faster. Okay, and because of that, the time taken is actually shorter. Okay, so that's why students need to know that the scenario whereby the speed of sound can be affected. For example, if I have humidity, the amount of water molecules. If the humidity of the air is higher, more humid, more water molecules. So in the air, I have water and air molecules now. So the more humid, the higher the humidity, the faster sound, the collision will occur, the faster sound will travel. So in the humid weather, like now, raining, where you'll find that the sound actually travel faster or more effectively compared to dry weather, dry environment. Okay, so humidity of the surface and humidity of the environment, okay, and followed by the temperature of the environment. The higher the humidity, the higher the temperature, the faster is the sound. Okay, so just take note of this. Now the next section that we have is the roller coaster question. Now roller coaster question is the conservation, is the energy. Okay, now I will not dwell too much on the definitions. Principle of definition of conservation of energy. You have to memorize everything. Okay. Now what happened here is energy stage here. Okay, so at A, this is inertia. B is final. Okay, the energy at A I'm looking out for is I have actually potential energy, which is EP. At B, at final, I actually have potential energy at B. Okay, but other than final stage, other than potential energy at B, okay, at B I also will have kinetic energy at B, because the roller coaster, when it reaches B, the roller coaster need to have some speed one. So if not, he will just stop at the top of the circle. So for him to move past the top of the circle, you need to have certain velocity. So at point B, the roller coaster is not stationary, it's still moving on, so it has certain speed. Okay, and on top of that, for the final phase, for the energy to convert initial to final. Other than that, based on the question is there is actually frictional loss. There's actually friction along the track from A to B. So which means that there is actually losses here. So at initial, the energy at EPA, okay, this is the only form of energy. This energy is actually transformed to various things. First, transform to EP, transform to EK, and lastly, transform to losses. Okay, so if you look at the energy conservation here, we have initial state is EPA converted to final energy, which is consists of EP at B, EK at B, and the energy loss due to friction. And of course, friction formula, you should know, it should be force some distance parallel. Okay, the force we are looking at is the friction force, which is 250 here. Okay, so once you have so-called make sense of the questions and make sense of the drawing, now you are ready to solve the question. Okay, now calculating A to B potential energy, loss in potential energy, I am from 30 meter, eventually I end with 20 meter. So I will safely say that I actually have a drop in height, which is 10 meter. Okay, so and because of that, you will find that the potential energy MGH is 80,000. Okay, then work done against friction. Remember, it's friction. Okay, so friction means the force is friction. Okay, distance traveled based on the question is along the track. Where is the track? The track is 120. Okay, so which means the distance parallel is 120, and you get the answer for your friction to be work done by friction will be 120. Sorry, 120 times 250, which is 30,000 joules. This is the energy loss due to friction. Okay, gain in kinetic energy. Okay, total energy you have is the total loss in potential energy. This 10 meter, this energy here. Okay, after you lost it, okay, after you convert from point A to point B, you have lose this energy due to your 10 meter loss in height. You lost your potential energy. This potential energy is converted to where? It's converted to kinetic energy plus heat loss. Okay, so your energy 80,000 actually includes some will be used up by friction. The rest will be used for kinetic energy, which is that's why I have this formula 80 minus 30,000. Okay, because eventually what I'm looking at is my loss in EP is actually converted to EK plus friction. Okay, so that's why to find friction, to find gain in kinetic energy, it will be EP minus friction. Okay, and stop it. Okay, remember when you talk about speed, don't use distance divided by time. A lot of us, we like to use the word distance divided by time for speed. This formula usually go where? This formula I always usually use it for sound, or when the question asks for average speed. Okay, speed of sound or average speed. When the question give you neither, I will usually the question give me neither like speed nor average speed. Usually, if I need to find speed, I will look for two things. I will use kinematics area under the graph. Okay, on the gradient, I'll use kinematics to find. I will draw velocity time graph to find the speed. If not, I will usually use energy. And one of the energy formula that has speed is actually your kinetic energy, half equal to mv squared. Okay, and from there, I can actually find the speed. Okay, so these are the formulas that usually we tend to see. Okay, now in reality, whether it's faster or slower, definitely in reality the speed will be actually slower. Because why? But in reality, other than friction, here what we have is friction at track. In reality, I also have friction due to air, and it could also be the fact that maybe the mass of the objects or mass of the truck, okay, it may not be exactly 800 kg. It may be slightly, maybe 799, all these things. So we will not know. But definitely, based on the question is, I did not factor in the friction due to air. it is actually a big thing. If you look in real life, air resistance, the resistance due to air is actually a lot, especially when your truck is of a certain surface, of a certain height, every rushing through the air, a lot of energy will be lost due to air resistance. Okay, so this air resistance friction due to air resistance, or work done due to friction of air resistance is actually a big portion. And because of that, the speed of the truck will actually be further reduced. Okay, and with this will be the last question for this mid-year exam. Okay, remember, okay, to tackle physics question, your fundamental is definitely the most important. Okay, but other than fundamental, once you practice the fundamentals, the next step that you proceed on should be actually to practice the paper, to get exposed to the questions, to see how you actually craft your answers, to craft your thinking, craft your learning, okay, to formulate different answers that will suit the questions, that will allow you to score. Okay, so end of the day, it's like there's no perfect way to study physics or to score for physics except hard work, consistent work. Okay, if you have any problem or if I make any mistakes in any of the explanation or the debrief, okay, just feel free to drop me a message, okay, either email or you can draw a comment and below the YouTube below the YouTube video, where then I'll get back to you. Okay, if not, thank you and all the best for your O level.